take a look at graphing translations of simple rational functions. So to graph a rational function of the form y equals a over x minus h plus k, we're going to follow these steps. Now really what we're going to do is we're going to use transformations. So remember when it's with the x here, with the x, remember that's a horizontal translation, so it's left or right and it's opposite of the sign. And then when it's outside here to the right of it, that's going to be our vertical shift up or down. And so one way that I want to look at it instead is that when we're going to look at their translation, so say for instance this is right 2 up 5, then what we're going to do is we're going to move that original origin, we're going to move it right 2 up 5, and then we're going to use that new origin as our starting point to graph a simple rational function. And so again, that simple rational function is going to be this a over x. So just going back to graphing the negative 6 over x, for example, we really could just look at it. We don't have to do a table. Just take a look at negative 6 over x. And then just think about what numbers are great to plug in. Now, 1 is always perfect, right? So if you plug in 1, you know you're going to get a negative 6. Then whatever that number is on top, that numerator is, pick that same exact number. So if it's negative 6, choose a regular 6, a positive 6, and then later on a negative 6. Because that's going to get you a 1, right? A number over itself is 1. So that's a great starting point to graphing rational functions. And then what you can do after that to choose some more points is, if it's possible, if it's not prime, you can pick other numbers that divide evenly into that numerator. So for example, you would choose 2, right? 2 goes into 6 3 times. And then so you would get a negative 3. And then if you plug in 3, 3 goes into 6 nicely, then you get this point here at negative 2. So we're going to use that information, what we know about translations, to graph this instead of filling out the entire table. So first, let's just take a look at how is this translated. So with the x down here, we know x plus 2, that means that is left 2, right? Positive 2 means left 2. It's opposite of whatever there is. And so this moves left 2. And that makes sense because x cannot equal negative 2, right? We would get a 0 in the denominator. So this is left 2, and then this means down 1. So let's use that information. I'm going to rewrite it over here. We're doing left 2 and down 1. Then we're going to graph the simple rational function, and that simple rational function is going to be negative 4 over x. Okay, so let me rewrite that here. We want to graph the simple function negative 4 over x. So what we're going to do is we're going to move our origin. Our origin is here at 0, 0. And so what we want to do is move it left 2 down 1. So move it left 2 down 1. Go ahead and plot a point there. Now at that point, what you're going to do is draw your asymptotes at that point. So that point designates where that new origin is. And so now that we moved it left 2 down 1, we're going to focus on this negative 4 over x. And so from the new origin, negative 4 over x, let's pick some great points to plug in there. Negative 4 over x, so I said 1 is always good. So if you plug in 1, negative 4 over 1, that's going to be a negative 4. 1, 2, 3, 4. What else is a good number to plug in this denominator? That'll go in really nicely. 2. 2 goes into negative 4 very nicely because negative 4 over 2 is going to be a negative 2. So write 2 from the new origin down 2. Oops, down 2. Here. Then the other really good number to pick, negative 4 over 4, because negative 4 over 4 is a negative 1. And then so here is the graph. Then on the left side, so we always need one on the right and on the left, the branch on the right and the left. So on the left side, we're going to pick negative 1. So negative 4 over negative 1, that's going to be a positive 4, right? And hopefully you can do this just by looking at this. Now, you pick 1, and then you pick negative 1, and then you pick negative 4, because negative 4 over negative 4 is a positive 1. And then so that is going to be here, right? Again, using that new origin. Then you pick negative 2, negative 2, and then you go up 2, right? Because negative 4 over negative 2 is a positive 2, and there is the other branch. So there's always two branches to a hyperbola here. So now let's talk about the domain and range. So let's label our new origin. Their new origin was here, and so that ordered pair is negative 2 and a negative 1. So remember, the negative 2 represents our x, and our y is the negative 1. Domain has to do with our x values. So in this case, the domain is all real numbers x, all real numbers x, except x when x equals the negative 2. For the range is all real numbers y, except y equals this number here, the negative 1. And so if you label that origin with those with where it intersects here, where you moved it, then that helps you with your domain and range. So go ahead and try that here with number 2 and 4. Now you don't need to fill out a table or anything. I think you could do it just by thinking about transformations, as well as looking at the a over x, the simple function here. I think that'll be very helpful. So try these out, and then when you come back, I will go over how to graph that. So number 2, that is just translated. So there's no left or right. It's just down 2. So down 2. So if I graph that, down 2 is here. So it's not shifted to left or right, just down 2. So here is our asymptote. And then we want to graph the simple rational function 3 over x. So 3 over x, in this case, we're only going to get 2 good points that are on the grid lines. So always pick one. Oh, here's our other asymptote here, right? Can't get that. So you pick 1. 3 over 1 is 3. Then the next point you picked is that same numerator, which is 3, because 3 over 3 is 1. And so 2 good points without having to get fractions is there. Then you pick the other side. So we want to pick negative numbers. So negative 1, you get a negative 3 from that new origin. Then again, you pick a negative 3. Negative 3 over negative 3 is a negative 1. And so here is this graph. This new origin is at x is 0, y is negative 2. So the domain is all real numbers x, except x equals 0. And then all real numbers y, except y equals negative 2. So trying this one, if you try that one, this is great. So maybe I'm going to change it to a 2 on the top. Okay, so sorry, let me change this to a 2. And because I like that number just so it's a little different than what we've done before. So we're going to focus on graphing 2 over x. But we know this is translated right 1 up 5. Right 1 up 5. Right 1 up 5 is here. And so there is my asymptote. And then 2 over x. So again, we're only going to get 2 branches, or 2 points on each branch. So we pick 1. 2 over 1 is 2. 2 over 2 is 1. And then here is our graph. Then we have to go in the other side. So if you plug in negative 1, so from our new origin, negative 1, you'd go down 2. And then you pick negative 2, and you would get negative 1. And there is a graph. This point here, just to talk about our domain and range again, is 1, 5. So our domain is all real number x, except x equals 1. All real numbers y, except y equals 5. Again, pulling that from this ordered pair right here, 1 and 5.